raw, chop it in half, it's 16, double it times 3. We got 48, which mean a whole lot of cream. Divide the profit by 4, subtract it by 8. We back to 16, now add the other 2 that mega bring it.
Keep it simple today. Hey, so one of the most common misconceptions in mathematics, post arithmetic and getting into like algebra, is the concept of a coefficient and its variable. So you have 4 main operations. You got addition, subtraction, multiplication, and division. Everything builds off of that. So I'm kind of go into that for a second. Before I go into that, let's talk to the parents for 1 second. Please, please, please stop telling us educators that your children aren't good at math because you not. Last thing we want to hear. Bad thing about saying stuff like that is your children actually believe it. I believe they can do better, but they believe you, right? So stop telling them that they can't do it. Start telling them that they can. Maybe when I start telling them they can, we can work together. So you have addition, subtraction, multiplication, and division. That's like the engine, right? That's kind of what drives everything, right? But math is like reasoning, logic, pattern recognition, those types of things that you already know how to do. This is an example I like to give all the time. I ask my students, what do they see? They say they see a box. I'm like, okay, cool. How many boxes do you see? They say, okay, I see 1 box. Cool. So they kind of get it, right? All right, so they see 1 box. That's what they see. They see 1 box. Anywhere on here do you see a 1? I don't see a 1 anywhere over here, but they can tell me they got 1 box. I also asked them, do we actually know what's inside of the box? They was like, what's inside of the box? No one knows because they haven't opened the box up yet. But we do know we have 1 box. Does that make sense? 1 box, but we don't know what's inside. All right, so the 1 is the coefficient. The box is the variable. All right, 1 is the coefficient. Box is the variable. Make sense? Nah. All right, so let's look at this. I have a triangle plus 2 squares plus 2 triangles, right? Notice how I don't see any numbers sitting there, but just by looking at it, you know you have how many squares? What, 2 of them? 3 triangles? Yeah. So we have 3 triangles plus 2 squares. So this is when we start losing people, really. When we start throwing these letters into the mix, a lot of people are like, man, I thought this is math. Why are we dealing with letters? Well, I thought math was just numbers. But if you understand this right behind me, you should understand that. So how many do you see? Okay, I see 3 X's. And I see 2 Y's. So how many I see? No different from these shapes. All right, yeah, so I hope that kind of helps or whatever. I'm not going to go through any, like, super difficult examples today, but this is real fundamental, though. Like, you got to understand these concepts to build on them. Got to. As long as they have the same shape, you can add them up. 3 triangles? Okay, cool. 3 triangles. 2 squares plus 2 squares. It's done. Simplified. As long as they have the same variable, you can add them up. How many X's? 3 X's. Okay, 3 X's. 2 Y's. Simplified. Using letters.